who we are as a club. We are SFX, and our purpose as a club is to hold hackathons. We're having our annual hackathon in March of 2021, so you can stay tuned for some flyers, some Google Forms that will come through to you guys. But until then, this semester, we've been holding the series of workshops. We had our web dev one 2 weeks ago. Now we're having our mobile app dev. And yeah, we just want to bring a community of CS majors or non-CS majors who are interested into CS and just introducing the student body to things they maybe haven't touched on before. Next, I'll pass it on to the ACM people, Melissa.
Hi, I'm Melissa. I'm the current president of the ACM, and our club's purpose is to gain or to provide resources to the students and build a community. And we are co-hosting these workshops along as hosting speakers from the ACM's international organization. So I believe our next one's going to be next Tuesday, and the flyer for that will be on the Slack. So you can always join us. Our last two speakers, one talked about ethics and the other speaker was teaching about how to design your algorithms efficiently and effectively. And so, yeah, come by, stay tuned to our Slack. It's where we post all our flyers and a lot of other clubs and organizations post as well.
Awesome. Now I'm going to pass it on to our presenter, Chris. If you guys have any questions throughout the workshop, please unmute yourself and say them, or you can also type them in the chat and we will make sure to get to them. Okay, I will give the screen sharing abilities to Chris for now.
Okay. Let me get this. All right, can you all see that now?
Yes, we can.
Oh, okay, great.
Yep, see it.
All right, here's the most boring slide about me. I'm a mobile engineering manager at Zillow Group. I imagine you've heard of Zillow. If not, you can ask me later. I've been a mobile software engineer for the last 10 years and many years of software before that. I've worked at startups and large technology companies. The icons I put here were only the large companies. You can imagine in between those companies, there were little startups that got gobbled up by those large companies. So I've worked at very large companies and very small. I also been a lecturer at San Francisco State since about 2016. My personal education is mostly, well, a couple different universities, but most of it was at University of Illinois back in the day. So that's about me. So it's our agenda tonight. We're gonna look at Android Studio, which is the main IDE that most people will use for developing Android apps. We'll talk about virtual devices and the emulator. We'll talk about the key artifacts of an Android app. We'll talk about layouts and views. We'll talk about activity lifecycle, which probably doesn't mean anything to you now, but hopefully it will a little bit later. We'll talk about logging, processes and threads, network utilization and retrofit, which is an extremely handy library that many apps that you find in the Play Store will be using. We'll talk about persistence a little bit, and we're going to have exercises interspersed. So the slides will have all the exercise code and instructions, and I will be doing it live with you as we go along this evening. Okay. Okay, so mobile. What's different about mobile versus any other software that you might have done before? Well, if you think about if you just wrote a basic Java program, in your Java program you have a main method, which is your entry point to your program. So, and your main method starts. Basically control is in your application. Yeah, you might call some system libraries and those return, but control mainly exists in your application. Mobile doesn't really have a main method. It has something that replaces it, but not really a main method. So most of the software you're going to be writing actually gets invoked via callback methods. And so the operating system really has principal control, and then through these callbacks gives us opportunity to run the code that we write. Okay. So let's get started first. Android Studio, I don't know if any of you have done this yet, but I'm going to do this real quick just to get us kicked off. They have a nice little wizard at the beginning when you open up Android Studio, and you can select the template of different kinds of apps that you want, and it will generate code for you. So let's do that right now. We're on Android Studio, say create a new project. We're going to select empty activity, and I'll explain what an activity is in a minute. And we're going to call this SF Hacks demo. You can see it generated a default package name. Package names are in sort of a reverse URL format. This is important if you ever want to deploy to the Google Play Store, actually, have it do distribution to the Play Store, because this needs to be a unique name for your app, okay? This is the location where it's going to store our files. We picked Java. The other option is Kotlin, but I sort of guess that most of you haven't had exposure to Kotlin, so we're going to stick with Java this evening. Then you have a min SDK. Min SDK just basically says how far back do you want to support operating systems? So, if you want to support only very recent operating systems, you would pick a higher API number, or if you want support older operating systems, you would pick something like 24. So you could say finish here, and basically, while we're waiting for it to load, we've generated some code, I hope. Okay, you can see down at the bottom, this great old build model. It's one more process, so it's taking a little bit of a while. I can hear the fans going. Okay, yeah.
Okay, so when I was like doing some app development, I was looking up in the website for deploying applications, and they said you had to have a specific like kind of like a specific what do you call that, version of Kotlin or whatever, in order to put into the App Store, else you wouldn't take it.
Yeah.
Is that true, or you can still use like lower versions of like SDK?
Of the Kotlin version?
Yeah, because like there's like I remember I was trying to put something in the App Store, and then like they were saying that you have to have a specific SDK in order for you to place it in the App Store. I'm not sure if the Play Store. I'm not sure if like that was really applicable.
I'm not aware of that restriction, but yeah, if you can find a reference to it, I can address that if that's actually true or not. I wouldn't imagine it being true. Kotlin is a JVM language. So, I mean, at the end of the day, it all gets compiled down to bytecode. And I've not heard of a restriction of a certain Kotlin version, but if you find a reference to it, let me know. Okay. So you can see here that we've got some code generated, and it's in our project, and we'll talk a little bit what. Hello?
Chris?
Yes.
It's taking really long. Is that normal?
What's taking long?
The building of the project. It's still loading on my SSD machine.
I have the same problem too. Mine's still loading.
Yeah, like I have SSD, but it's still loading. Like it's like 30% done, but the bar is still like loading.
Yeah, it usually doesn't take that long. Mine took a little bit longer than I expected this evening, but no. I mean,
okay,
there's a lot of variables, right? It's going to be, how much memory do you have? With your CPU. But no, it usually takes no more than a few seconds.
Okay, cool. Thank you. It's done. Thank you.
Okay. Okay, so we got some code generated for us, but we'll let's get back to the slides and before we go mess around with this code. Let's take a look at what it did for us. So in our IDE that we just opened up, various parts of the IDE. If you've ever used IntelliJ for Java development, Android Studio is going to look a lot like IntelliJ. Android Studio is based on IntelliJ. So basically JetBrains, which builds IntelliJ, also builds Android Studio. So, you know, at the top, you have your normal toolbars you see in most IDEs, cut, copy, paste. You have this little play icon, which we'll talk about a little bit later. You have your navigation bar here, which basically we have a main activity open and it tells you sort of what's the path down to that. Then we have these, you know, well, of course, the editor window over here, number 3, that's where our source, we're going to edit our source code. And we have toolbar windows all around the sides. So these on this side are basically showing us what view we're going to see here. We default to project view. But also down here, we can select different views where we might want to see what's going on with the debugger. We might want to see what's going on. We might want to use a terminal. We can, there's another option for looking at the logs, which we'll see a little bit later. And then on this right side, we can look at the different Gradle tasks, and we'll talk about what Gradle is a little bit later. The other things of note, not in this view, and which we'll see in some other slides in the IDE, is the layout editor and the AVD manager. We'll get to those in a few seconds. So the little navigation tips, which are kind of handy. Oops, let me go back to that. These little buttons are quite handy. So for example, if you have a particular file open in the selected in your editor and you want to see where is that in the structure of my whole project, you can click this button on the left and that'll basically navigate to and open up basically the file structure to where that thing is. So that helps you find where that is in your whole project. Then if you got a whole lot of things opened up and expanded out and you want that to close, you just hit the collapse all. Show menus gives you some options about how things are displayed in this project window. And then hide, you'll see this on a lot of sections of the IDE. That's handy if you just want to hide a section temporarily to give you some more real estate on your screen. Here's some common keyboard shortcuts: Control F to find, Control R to replace. You have, that's pretty similar to other IDEs. A couple that I use pretty often is Control B, which basically finds the declaration of whatever you're looking at. You can use this on classes. You can use this on resource files. So that's a very handy thing because sometimes you're looking at a reference to something and you go, where is that thing declared? Where can I go find out what that thing is? What does that class or what does that layout look like? So that's a very handy one. And then Control Shift F is a very broad search, not just in your file that you are now, but basically you can search your whole project by using that. If you're using a Mac, you will use Command instead of Control. And at the end of the slide deck, I put a link to where you can find a complete list of keyboard shortcuts because everyone has their own preferences of, you know, what they use as they develop. So. Okay, so the Android Device Manager or AVD Manager. So in your IDE, if you go under Tools, we'll find the AVD Manager. So what is an Android virtual device? Basically, it's a profile of it's a profile of a device that you want to emulate. So as you're developing, you're going to want to test out your app. See, how does it run? Does it behave how I think it is? Does it look how I want it? So, of course, we can connect devices to it, and we can talk about that later too, but it'd be handy just to have software that you could basically run a configuration. So you can see here, we could have what type of device where this icon here tells you that's either a tablet or a phone. You could also emulate a watch or TV, so there's different device types. You can give your device a name. You can just say whether you want the Play Store installed on your device. Your screen resolutions, because Android devices come in a lot of different shapes and sizes, many more shapes and sizes than iOS devices. So that's an important thing, because you might want to see, okay, well, my app looks great on a large device, but how's it going to look on a small device, or vice versa? So that's an important thing, to have a variety of device sizes and resolutions. API level and target OS are practically the same thing. They're pretty redundant. The CPU ABI here, you can see x86 here. Even though you will be very hard pressed to find an Android or physical Android device that runs on an x86 chip. The reason that most emulators, you will want to use x86, because that can be emulated more easily on your laptop, which most people, whether you have a Windows or Mac machine or even a Linux machine, is probably running an x86 chip. So that can be emulated much faster and more efficiently. So for an emulator, just default to x86. Then you can also decide, what image size you want, how much, space for RAM and disk do you want. And then actions, you can basically start up your emulators, edit, and so it's basically, it's basically your library of types of devices you can use. So what do you do with these things? Well, you use the emulator. And when you use the emulator loads one of those virtual devices, and that gives the emulator its sort of look to it, how its size, shape, resolution, and things like that. There's a bar of quick buttons that you can use to up the volume, rotate the device left and right, take a photo, various little quick buttons here. And then at the bottom, you can't see it here because I've overlapped it with this screen. There's a more menu, which can pop up this, and you can even define like a location. So obviously this software emulator is not going to have a GPS radio on it. So if you want to just simulate a geolocation, you can basically set the geolocation here. And when you open up like a maps application, you would see that location on your emulator. So, So things you can do, you can make calls, text, rotations, and you can even use a network. So emulator is a very handy development tool. All right, so enough talking about the emulator. Why don't we just use one? So we have our generated app here. So we're going to click the Run App button. And what's that's going to do? It's actually going to build the source that was generated for us. It's going to include the resources. We'll talk about what those are, which basically images and some XML. And then it's going to install this onto our virtual device and start the app. So here we go. It all goes well. We can see down here in the status bar, Gradle is running. And this up a little bit. Gradle is running. Oh, hang on. I might accidentally click on something. Okay, it's doing the install. All right. And our bare bones Hello World app is installed. Okay. If I want to see like what it looks like rotated, we'll do that. Rotate it back. All right. So we're running our generated app in the emulator.
Excuse me?
Yeah.
I'm getting an error when I try to run it where it's saying that it needs the hypervisor driver for AMD processors. And then when it tries to install it, it says that the installation has failed.
Okay.
I'm on Windows, by the way.
Yeah. So I've never gotten that error. I develop on Mac. So I've never seen that error. So sorry, I don't have the answer off the top of my head.
Okay.
Google
I'll keep
Stack
if
Overflow.
someone else is having. Yeah.
Chris, when I
Yeah.
ran the application, I see the same thing you do, but the font size is slightly different. That's normal, right? I mean, I also use Windows too, just like the other person who just did it.
So font size where?
In the app, it says so like it looks like a phone, like it's an emulator, I think.
Yeah. Right.
And just hello world, but the font, yeah.
So that's going to depend on what your emulator, which device you picked,
Okay.
and the resolution. Each type of device and each API level, which is basically operating system, is going to have its defaults.
I see. Okay.
Right? And defaults can be overridden in layouts, but you're basically hitting whatever the default medium font is for a text view.
So Chris, I remember when we started the project, you chose like a different version for the setting. Can that be changed afterwards without rebuilding the app?
A different version for this.
So I remember like the column whatever thing. So like if I chose a different version for the I forgot why I chose, but doesn't matter. When we started the project, you chose the not the Java column, but there's something else you chose under the different version. I think I chose like
API
Android.
level?
Yeah, API level. I chose 24. That wouldn't matter. Right?
Yeah, you can change that. Yeah, the API level can be changed later. It's basically, if you search for SDK or min SDK, target SDK.
I mean, like, would it if I change it like mid project, would that do I need to restart the project, or would it be fine? Would it be fine? Do I need to like redo everything? It's the API specific. That's why I'm asking the project.
Okay.
Yeah.
So if you change it afterwards and you try to compile, you may get some errors because let's say, for example, your target SDK or API was, let's say 28.
Okay.
So you're building code based on the APIs of version 28. But now you decide you want to support API 24.
Oh.
Well, some devices at API 24 may not support all of the API changes that 28 has. So so you're going to get compile errors, or you might.
Okay.
Depends.
Okay.
So if that happens, the IDE will tell you, alert you to those, target those, and it will even give you suggestions of workarounds.
Okay, I understand. Thank you.
Yep. Yeah, good question. All right, so we've ran our app, and so let's talk a little bit more about some of our artifacts. So over here in Android Studio, we have our project level here. We open up this and we have a manifest. So a manifest is basically an XML file that gives a lot of information to the system about our app. So our package name, which is our ID, if this thing is allowing system backups in the cloud, what its icon looks like. So when it's installed on a phone, what does this icon look like? What's its label? Most importantly here is its activity. And let me pull this in front. I'll talk about that a little bit later. But other things we see here, under Java, you see our source code, which we only have one file right now. You'll see some highlighted folders here. These are test folders. So if you were going to write a unit test or an instrumented test, you would write these tests here. So it actually generated example tests, but these dummy tests don't do anything other than verify that 2 + 2 = 4. But if you wanted to write a real unit test, so if you had a method that had an algorithm in it, you want to make sure that that method is going to work every time, just like writing any Java JUnit test, you could write a unit test here. Instrumented tests are meant for tests that are dependent on Android API, so they're not pure Android So we can talk about that later if you want to get into it. But anyway, the highlighted folders are for your automated tests. So here is your generated things. Resources here. These are things that your app uses which are not code, or so to speak. So you can have drawables, which are XML, just basically, and a layout, which is XML. That's very important. We're going to talk a lot about layout a little bit later. Bitmaps is another type of graphic resource. And then you can also have values. Like you could define a number of colors. You can define them in RGB hex codes. Strings you could put in here. So you're not embedding strings all through your source code. That's a particularly bad thing to do if you ever want to localize your app with different languages. And then also you can make different themes for your app. So themes are and styles we're not getting into tonight, but if you're curious about themes and styles at the end, we can talk about it. And then at the bottom here, we have Gradle scripts. So Android Studio uses Gradle for build systems, kind of like, you know, Maven or Ant. So it's basically these files define the dependencies of our app, version levels, what external libraries we're going to need. So a little bit later in the exercise, I'll show you how we use Gradle files for our build. Okay. All right. All right. So going on. So the manifest, we talked about that. So let me just show you that manifest. Oh, we already talked about the manifest. So yeah, the three main artifacts that we generate here was the manifest, an activity class. So this is some Java code that it generated for us. It's very brief and small, but we'll be expanding that this evening. But activities in general could be written in Kotlin or Java. At the end of the day, it'll be compiled down to bytecode and run on a virtual machine. Resources, I just talked about the resources where we have colors and strings, basic XML files here, or they might be image files like PNG files and things like that. So those are the main artifacts that we just generated. And like I said, we'll be expanding on those this evening. Yeah, Android manifest we talked about a little bit earlier. Has our package name, which is our ID, our icon, app name. You know, important thing here I want to point out, when I said there was no main method in an Android app, that's true. However, there is an activity that you should basically label it to handle an intent. So this is an intent filter. So an intent is a message in Android operating system. An intent is a message sent out. A message could be sent out broadly to any app on the system, or an intent could be sent within an app. So basically, this intent is saying, this intent filter says, you know, if there's an intent that wants, that's a main intent from the launcher, and it's coming to this app, then this is where the app should start. It should start this activity. An activity is a basic UI component, which we'll talk about a little bit. So this is basically where our app should start. All right? So there's no main method. It's a main intent action that we're going to handle. We're saying if this message goes to our app from the system, this is where the system should start our app. Okay? So an Android activity is the basic UI component in Android. 99% of Android apps are going to have at least one activity. Some are going to have many activities. There are other types of Android UI components, but this is the principal one, and you generally have at least one of these. It's subclasses from an SDK class. So you're usually going to have an extends here, and an app compat activity is one of the SDK's activity classes. And this activity is going to receive callbacks that we mentioned before. So on those callbacks, you'll see this override annotation. And the reason that that's there, that helps the lint processor, because the lint processor will look for where these overrides are, and it will make sure that whatever's below this is actually overriding something in your superclass. And it will say, if it doesn't recognize this method, they'll say, this is overriding something that I don't understand. You've got an error. Okay. So the callbacks come from system events and user events. So we'll see we'll see those in as we do some coding. And by the way, these callbacks happen on the main thread. We'll talk about threading a little bit later, but it's important to remember that. We'll get to threading a little bit later. So the onCreate was generated for us. We need to have that. And it's basically the responsibility of the onCreate callback is to set the screen layout. We see here, set content view. You see it both here in the slide and here in the code. Set content view basically says, this is what this activity should look like. And you can see it has a reference to a layout, which happens to be this XML layout here. We'll talk more about layouts a little bit later, but that's the main job of this onCreate. It has to set the content so we know what this thing is going to look like, how it should be rendered onto the screen. The other thing that the onCreate method usually does is once we've set that content, we might need handles to some of the parts of that UI. And in our exercises, we'll see how we get those handles to it so that we can interact with the user interface. Okay, so the layout defines a view hierarchy. So any screen that you see in Android, there is a hierarchy of views, and basically through the structure of the XML document, you can see that hierarchy. Hierarchies include views and view groups. The one we've generated here is very simple. It has one view group, which is the constraint layout, and it has one view inside of it. Our diagram down here shows a more complex view hierarchy, but the views and the view groups basically specify the rectangular space that they will take up on the screen. This XML at runtime is inflated into actual Java view objects. So basically, when we hand that XML to the set content view, the API, Android API, is basically instantiating those Java view objects for us. So the layout editor allows us to view our code in our layout in code view. We can view it in design view, which and that's that. Here's the design view. It's pretty boring right now because we only have one view in there. Or you can do a split view like this, which works a lot better when you have a little bit more real estate. But well, we'll do some exercises with that. So, so some common layouts that you will encounter. The default one that was generated here for us was constraint layout. So our exercises will do a little some work with constraint layout. But other common layouts you will encounter in Android development are linear layout and frame layout. Okay. Basically, the layout is a sort of an invisible structure around your views. It helps organize your views on the screen. Yeah, that's where it was. Okay. Constraint layout. So this is one we're using this evening. So constraint layout, you can see it here in the slide, both in the code or XML view, and then down here in the design view. When you put views into a constraint layout and you're looking at the design view, you'll see these handles. You see these blue dots here or these white dots over here. These handles allow you to create relationships or associations. And those relationships or associations are the constraints of the constraint layout. So you see these squiggly lines. That's basically saying this view, its top, right, left, and bottom have relationships to the sides of the parent view. You can also make relationships or constraints to other views in the layout as well. But basically on all 4 of those dimensions, you want to have a constraint going to something. And if you don't, you're going to get a lint error and compile error. So you kind of have to make sure you have that done. Once you've added these constraints, they will appear in your XML as attributes on the text view itself. So this little text that says hello world is a text view. And its text says hello world, and it has 4 constraints, as we can see in the design view as well. Okay? You can get fancy with the constraints layout, but we'll keep it kind of basic for this evening. Okay, so Android views, as I mentioned, they are UI classes. They actually are not just purely XML. At runtime, they become actual Java or Kotlin or bytecode classes. So you can see in our view group might have another view group under it. It might have a profile pic. Well, actually, this is a label, and it might have a profile pic. And then in the lower, sub-view group, we might have another label with name. We might have an edit text, which is it's a subclass of text view, which actually allows you to edit it. That's where you would enter text. And another view type is called button. All of these types of views, all subclass from the view class. As I mentioned before, they're automatically instantiated or inflated from the layout when the XML is passed to set content. Views can also be added and removed in code if you want to do that. The reason that most of the time you define them in the layout editor and with XML, because it's easier for the IDE tools to give you a preview of that and let you visualize that, versus whether, if you were building views down some code path, it doesn't know which code path to follow to give you a preview, right? Whereas this way, we can just set it up in XML and we can view it both in code or design or both at the same time. So not that you can't add views with code, but it's more often you're going to add views in a layout like this. Okay, so we're going to do a little exercise with our layout editor. Okay, so let's do this. Let's go to our layout, and we're going to go to design view, and we want to look at our palette. Okay, and under palette, let's see if I can make this. Let's collapse this for now, so you can see what I'm doing a little better. So I'm going to take a button, and we'll drag and drop this button down here. So you see the UI lets me do that, but I have 4 handles, and those handles don't have any associations yet, right? So I'm going to need to do that, otherwise soon I will get some errors. So I just made a constraint to the bottom. So that button has a constraint to the bottom. I'm going to actually constrain it to the other view. As I said, you can constrain to both the parent, as I'm doing with the bottom and the sides, and you can constrain it to the other view. All right, so our view has 4 constraints, so we shouldn't get any lint or compile errors. But you know what? The name is kind of boring. So this ID is kind of how this thing is referenced in our XML and also in our Java code. So I'm going to name this demo button.
Chris, I'm sorry. How do you constrain the button without moving it? So I've been trying to constrain it, but it's been moving the actual button. How did you constrain the? I guess yeah.
So I'm doing it in a sort of a smaller view, so you guys can see what's going on.
Mhm.
I would basically zoom in, and another thing you can do is
So I want to know that what you had to click on to actually constrain it without moving the I guess
well,
the
if
aspect.
it's constrained on one side and not the other side, it's going to move, right?
So you just click on the circle thing to constrain
Yeah,
it.
you click on the circle thing.
Okay.
Now technically, you could also just go to the XML, but I wanted to show you how to do it in the design view.
Okay.
Because so I'll show you the XML in a second. But so we changed the ID of our button, which is fine. And let's go to split view. And now you can see in the XML, we have the button here. It's somehow the IDE is not updating. Let's see. Something's doing weird here. Yeah, something strange going on. Go back to that button. ID is not behaving. Demo button. Okay. All right. See, the demo button said, hey, it realizes there's references to this button already in the generated XML. So it's saying, do you want me to fix that or refactor?
Chris,
Yes.
there was someone asking in the chat, but why are there two different color views on there?
Okay. Yeah. So let me finish this and I'll explain it. All right.
Thanks. Sorry.
We're basically, because we just changed something in the attributes window, we've changed something's ID, and the ID is already being referenced in the XML, we're potentially breaking something. So the ID is telling us, hey, you're changing this ID. Do you want me to refactor so this ID reference? I say yes. And you can see over in the XML, it's now called demo button, and it's going to work fine. So, questions, what is the two views? Okay, so this is the real like UI view, and this is called the blueprint view. So views can have states of visibility states. They have 3 visibility states. A view can be visible, it can be invisible, and it can be gone. Now, the view still is there, but it might not be visible at the moment. And so it's possible I could have, let's say, well, let me do this. I'll take this demo button and let's just say visibility. We're going to set its visibility to invisible. All right. So you can see from this view, you don't see it anymore. But the blueprint view still knows it's there. Okay? Does that make sense? What the difference is? Well, hopefully, yeah. Let's put this back to visible. Gone actually means it's not visible and it's not taking up any real estate. So that's an even trickier one. The things will start, if anything has a relationship to it, those things will start shifting if you set it to gone.
Chris, I'm sorry. Where is the activity main.xml?
Where is it?
Yeah, because I changed the buttons to a different ID, but it's giving me warnings and errors. I'm trying to figure out where the file is so I can change it manually. Thank you.
Okay, so you go to your project, you go under layout. Under resources and layout. It's up there. Okay.
Yes.
All right. So you can double click on it and open up here. Another way to do it is activity.main is referenced in our main activity. And I'm going to use one of our keyboard shortcuts. I'm going to Command B, and it opens it for me as well.
Okay, got it. Thank you.
Okay.
Thank you.
All right. So let's do one more thing in our layout exercise. Let's change the ID of our text view to demo text. I'm going to close that. So I'm going to change the ID here. And because this ID is being referenced in our XML by the demo button, remember the demo button has a relationship to it? Let me show that quickly. We collapse this. All right, so you see right here, there's a constraint to the text view. Now if I want to change its, if I change its name or its ID, basically the IDE, the layout editor realized you're about to break something because you're changing it because something has a reference to it. Would you like me to do a refactor to fix things for you? I said, yeah. So I did, and you can see now this line that now refers to demo text. Make sense? Okay. All right. So
when I load activity main XML, I only see the two phones. I don't see the actual file. Like it doesn't show the code. Is there a way to make the code show instead of the emulator?
Okay, can you repeat the question?
Yeah. So I navigated to activity underscore main XML, but when I double click on it, it loads the two phones, the two emulator, like yeah, that and that, but not the actual code that you're showing on in the middle of the screen. Yes.
See here, you can change views. You say code, design, or split.
Okay, I see it. Thank you so much. Thank you.
Okay. All right, cool. So that's little basics about how to edit layouts, both with XML. You could just type here if you wanted to. Oh, you know what? I'm going to show you, because I've been changing things in the attribute editor, I'm going to change things here. I'm going to say the text should be click here. So let's go see, now that I did that. Oh, I'll explain. See, what it's telling me is I should probably put this in a string resource file. Not that this won't work, so it's just a warning. I can ignore that for a while. If you want to go back, if you have time later, I'll show you how that is. But the point here is I edited the XML, and I go over to design view, and I zoom in a little bit. You're going to see, sure enough, the button says click here. Okay? All right, cool. All right. So let's go on. All right, so let's do a little source editor exercise. So for a source editor exercise, let's go to main activity. And we're going to follow along with the slides. And it says, use find view by ID. And we want to do that after we set content. And we want to get a reference to the text view. So let's say text view TV, or rename it anything we want, equals find view by ID. R dot ID, but then we change this name to demo text, right? Demo. Okay, cool. And it's Java, so we have to end with a semicolon. Now you can see the word text view is in red. That's because we've not imported it. So it's highlighting it and says, would you like to import it? So it'll give you a key stroke combination to do the import, and sure enough, the IDE kindly imported it from me here. Android.widget text. Okay, fine. Now, so now we have a reference to a text view. Let's again use find view by ID. This time, we're not going to assign the view to anything, but we still want to get a handle to this, at least temporarily. We want to get our demo button. All right, and our demo button. Now that we have a hold of it, we're going to set its on-click listener. So views, all views, not just buttons, have on-click listeners. So basically, we can get an event back from the system of when there has been a click or a touch in the rectangular space of that view. So if we're going to say set on-click listener, we need to instantiate that on-click listener. View.onClick listener. And you have to override the on-click method. That's the callback that we're going to get. That says we got a callback for onCreate, which is a system event. Here we're going to get an onClick, which is a user-initiated event. And we want to do something here. So let's say we're going to do set text to yo. All right. So let's run the app and see what happens when we do.
Chris, how do you manually change the ID to demo button? I changed it to something else, but I can't remember. So, like, how do you change it manually, like in the code?
If you're in design view, there's attributes on the right side. If you're in XML view,
yes,
you look for the text attribute.
Okay, if I'm right now in the XML view, what do I do? I'm sorry.
Look for the text attribute on that.
Okay, text attribute.
The Android :text
Okay.
equals. Okay. All right. So here's our new button in our UI. And if I say click here, it says yo. So basically, we've been able to detect an event on our UI, and we've been able to respond to it in the UI. Both of these things have happened on the UI thread, by the way, but they need to happen on the UI thread. Events need to come in on the UI thread, and we can only update views on the UI thread. If you try to update views on a different thread, they won't update. We'll get into that a little bit later as well. Okay. So now we did that. Now let's do something just one little tweak to it. Let's go back to our activity, and let's create an integer. I'm going to call it count, that equal to 0. And you know what? In our onClick, instead of just having this say yo all the time, because if it says yo, we know it changed once, but is it getting all the clicks we're sending? So let's say count plus equals 1, right? And now we're going to say, so yo, we're going to say click count equals count. Right? So very simple change. Again, let's run our app. Let's say let's terminate the old one, start a new one. Succeeded. And let's click count 2, 3, 4, 5. So it's getting all of our events and it's responding to them. Okay. All right. Cool. So we can get events from the UI, we can respond to that and update the UI. Let's move on. All right. Okay, so Yeah, activity lifecycle. So activities, as you can see here, have a life cycle. So the activities transition through various states in their life cycle. And the good thing for you as a developer, you will get callback methods for all of these various states. So it allows you in your UI to respond to those changes of state. Some of these state changes happen only once. For example, onCreate is invoked, well, sort of once, unless the process is killed, but that's not common. But onDestroy is only called once. OnStart is the next one after onCreate, and then it goes to onResume. Even the first time it's onResume. Seems weirdly named, but that's true. And then once those three states have been passed, the activity is fully visible, fully running, fully capable of taking input from the user and updating its UI. So if you want code to sort of respond to these, if you want your code to respond to these state changes, you're going to override these lifecycle methods in the same way that we override onCreate. We overrode onCreate. Okay. The one restriction you need to do, like we did in onCreate, you need to call the superclass onCreate method. That implementation you have to call, otherwise, I think even the lint check won't even make it happen, but it will definitely do bad things at runtime if you don't do that, and you'll get nasty error messages. Okay? So just remember you need to do that. So, logging. So logging can be quite useful. So there's a system log on your Android device. And in that system log, you'll see logging messages from the operating system itself. You also see messages from various apps that are running. It's very useful to use the system log for running multi-threaded apps, because if you've ever written a multi-threaded app and you're creating breakpoints, you know that you're going to affect the behavior of your app, and that's not a very effective way to try to figure out what's going on. So a log message is going to have two parts, a tag and a message. The tag helps you sort of group messages into categories, helps you filter them, and they can be viewed down here, the lower part of your ID in the tab called log pack. So you can view this here, and in this area up here, you can filter by them, and you can even like specify, which app you want to watch the log running for. So a lot of good logging tools here. So let's do a little exercise with logging and the lifecycle. So we're going to first go back to our IDE, and we're going to create a constant, let's say private static final string tag equals main activity. You don't have to name it main activity, but it's useful for our purposes here. And then let's go back to our onCreate method. Let's say log D. So these logging methods are static methods. So D indicates this is a debugging method. So before I go on, I'm going to take the lint checks suggestion. Hey, you want to do an import of log? I said yes. And here I'm going to put tag that we just referenced, and I'm going to say onCreate. Okay. So then also I can do, let's override a couple, override, and affected, and resume. And remember, we have to call this super implementation onResume, and log D, tab, resume. And one more time, let's do the same thing. Connected, on pause, super pause, tag, oops, rad tag, and on pause. Okay, great. So the idea here is we've overridden these methods. We have some log messages, and if we run our app now, we should be able to see it go through some of these lifecycle changes. So let's go ahead. Let's actually, first, we're going to kill the current running app. Now we're going to start it anew. That's why we're not going to get a terminate message. Okay, so our app's running again. Now, let's go look for logcat down here. And let's filter by main activity. That one basically filtering by our tag. And you can see there's an on create and on resume. We didn't override on start, so we didn't see that. Okay, so that's good. That's what we expected. So I'm going to click this little square button, and that's going to put our app not in the foreground. So it's going to, we'll see it here. So it's not in the foreground. It's kind of in our, there's a virtual list of recent apps, and so that's considered a recent app, but it's not in the foreground right now. And you can see down here in logcat, the on pause method was called. So basically it went into on pause state. When it's on pause, it's basically still viewable, but it can't take any input from the user, right, as in its current state. Now, if I click here, I'm bringing it back up to the foreground, and you can see on resume is called. Okay. All right. So that's how you do logging and how you sort of detect what's going on with our life cycles. Let's move it up. Let's go. All right. Now, okay, process this thread. So under the covers of Android, there's a Linux operating system. So Android's apps run in a Linux process. And when you launch your app, the system will create the process for your app and will create your first thread for your app called the main thread. You can make other threads later, and usually you do, but the main thread is actually created for you. And that's the thread that you'll get that callback on create to basically define what your activity is going to look like. So this main thread is important. It's sometimes referred to as the UI thread. So those two terms are used interchangeably. Distributes events to the UI, also distribute events back to the app callbacks. We saw that in our little exercise. There's a couple of rules about the UI thread. Don't block it. The reason why you don't want to block the UI thread, the screen in your Android device wants to refresh at minimum 60 times a second, 60 frames per second. So that equates to about 16 milliseconds. So if you're doing any work that takes more than a few milliseconds, because you're not the only person using the UI thread, you could possibly block or cause a sort of stuttery behavior to the refresh of your screen. So you don't want to block the UI thread. The other thing, as I mentioned before, if you're doing any updates, like changing what those text views say, if you want to do any updates to UI, you need to do that on the UI thread. Otherwise, it just won't display. If you do block the UI thread for too long of a time, typically it's about 5 seconds. If you do that, well, that's a huge no-no because you've been blocking it for much longer than 16 milliseconds. But if you do that, you might see a little dialog pop up from the system saying, this application is not responding. Would you like to kill it? So the user has the option of killing your app at that time. And that's usually not a good experience. The user is going to think your app is, pretty trashy, and they're not going to want to run your app anymore. Even though it didn't technically crash on its own, that's not a good thing. So not all of you may have a lot of experience with threads, but I'm going to show you some ways to let some libraries take care of that. So, but if you ever want to do any advanced Android development, or you're really going to need to get comfortable with one of the different threading API options, and I'll talk about some of those. So this is a very common thread in mobile development. You get, events coming from a user or some other input. You need to respond to that thread. So your response might, that event, so that might be requesting some, maybe a query to a database that you have locally on your device. It might be querying an API that's on the network, whatever. That thing, whatever thing you're querying is likely to take more than a few milliseconds. And so that's why you want that on a background or worker thread. But once you have those results, and if you want to display them to the UI, assuming that's what you want to do, you need to get that result back to the UI thread, okay? So that you can update the UI. So I've listed 4, this is not exhaustive list, but I've listed 4 different ways of sort of handling this work passing between threads. One is async task. You can look this up in documentation. It's very simple to use. You only need to implement a couple methods, but in real life activities, in real life apps, I don't suggest you deploy anything production with async tasks, but if you're doing a hackathon, it might work fine. Also, handlers is a set of classes that Android gives you to basically have message queues on threads. So basically with handlers, you can set up a handler on both your UI and worker thread, and using this API, you can put messages on the queues of each thread, and those messages could include the request and the result of whatever that query work was. RxJava is a very widely used reactive stream library. It's very full-featured. It's complex. I wouldn't suggest diving right in that for a hackathon that you want to do in 1 or 2 days, but just so you're aware that it exists, and it's very, very widely used in production Android apps. In the last couple of years, there's a new type of concurrency API that's being used, but it's only supported in Kotlin. The ones I mentioned before are supported both in Java and Kotlin. But coroutines is a new one. It's like I said, it's native to the Kotlin language, and it's a very different paradigm, but it's a different way to handle concurrency. So if you ever do Kotlin development in the future, you have that option as well. And that would allow you to get rid of using any of the previous 3 options. Yeah. All right, so network utilization. So you have a mobile device, your mobile device has Wi-Fi and cellular connectivity. You probably want to use those at some point. Well, the good news is there's no coding difference for what type of connection you're going to be using, because mobile devices can move in between, cellular connection and Wi-Fi connection pretty seamlessly, and you want that to be seamless to your app. So you don't really have to code like, oh, when I'm on Wi-Fi, do this. When I'm on, cellular, do that. You can do that, but you don't have to. If you want to use a network, you have to add some extra permissions to your manifest, the Android manifest we looked at a little bit earlier. No big deal. Network requests cannot be done on the main thread. So if you try to do that, you're going to get error messages. So don't try to do that. So this evening we're going to do an exercise using a library called Retrofit. It's an open source library initiated from Square Square, engineers at Square did a lot of great open source libraries. It's a type-safe HTTP client. It handles threads automatically for you, so you don't even have to think about it. So that's the great thing about retrofit. So we're going to do a little exercise here. All right, so I'm going to go back to our IDE. Let's go back to our project. First thing we have to do is add those permissions to our manifest. So let me first grab that. I'm going to, because that's a lot of typing, I'm going to copy and paste this, not to bore you guys. So in our manifest, right here, I'm going to do that. And by the way, if you forget to put these permissions in and you write the network code and you run it, your app will crash and you will see a log message telling you you forgot to add the permission. All right. So the other thing we're going to do is we're going to our Gradle file down here. We have two Gradle files. One's for the project in general, and the other Gradle file is for our app module. Our app is fairly simple, so we only have one module. But if you have a complex app, you might have multiple modules. It's just a way to basically break down your app into basically, it helps with the compiler to not recompile everything if you've made a small change. So, but our app only has one module. So we want to open up this module here. We scroll down, we see dependencies. Dependencies, these are like Maven style dependencies. We specify a certain path, and these can be basically downloaded, installed for us when we build. So I'm going to add two dependencies for our retrofit library. And one is the basic retrofit, and one is for JSON. I'll explain what that is in a minute. So after we do this, I'm going to go up here, and this is the Gradle button. So I'm going to sync with Gradle. The reason I'm going to do that, it's going to detect that there's two dependencies I don't have yet, and basically those dependencies have been added to my project now. So if I didn't have those already on disk, they were downloaded, and I'm ready to build. All right, great. We got the first two, we got the first three tasks done. Now let's go back to our Java code, and let's create a new class. We'll call this user. Okay, so the public class user, it has a private string attribute called name, right? And let's create a constructor for it, public user string name. This name, and then I'm going to use an IDE thing, and I'm going to say, hey, let's go up to the menu, say code. I want you to generate some code for me. Generate me a getter and setter. For the string, yes, that's what I want you to do. Ah, great, you did that for me. So that's a little handy IDE trick, right? Cool. So we've done step one of our retrofit exercise. What's step two? Now we get into retrofit code. So let's go back here. Let's create a new, it says Java class, but we're actually going to pick interface. And I'm going to call this users API. And in users API, we are going to use the get annotation. That here. So for each endpoint you're going to want to hit, you're going to create an API method. So, so I'm using the suggestion. I'm going to import that. I'm also going to import list. And I need to import call. So basically, I'm specifying a get method, a get HTTP method. I have some endpoint called API called get all users, and that's all I need to specify here. Now I also need to create a retrofit client. So let's say new Java class retrofit client. Might seem like a bit of code, but remember it's going to do a lot of work for us because it's going to take care of our, basically our threading tools. So private static retrofit. Retrofit. Cut that. Okay. And I'm going to copy and paste that so I don't mess up any of that typing. That's our base URL that we're going to hit. So this is basically a public API that I found. So. And for time's sake, I'm going to copy this method, but I'll explain what's in this method. So here we have a get retrofit instance. So if our static retrofit is null, then we want to create this instance and basically creating a new retrofit builder with our base URL. We have a JSON converter factory. So JSON is a Java library for converting JSON to and from Java. So it's pretty handy because our response back from this API is going to be JSON. So this will basically convert it to that user Java object that we want to see. All right, so now what do we do? Let's go back to our main activity. And let's create a method to make this request. So again, let me copy this so not to, we're running this short on time. I'll copy it, but I will explain it. All right, so get users. So get users gets an instance of service from our get retrofit instance, and it has reference to our users API class. I'm going to accept that import suggestion. This import suggestion. Accept that. Response. Okay. So what's going on here? So basically, we get by using our a retrofit client and using the create method with our API interface, we get an instance of the service. We can call the get all users that we defined in the interface, and we get an instance of call. Then we say, with that, call will return a call. It's a type call of list of users. So when call, we can enqueue a callback. We're saying, hey, I want you to have this request. I'm giving you a callback. And when you get a response or you get a failure, call back on these methods. All right. So enqueue basically says, hey, here's a call. Go do this asynchronously on a background thread. But when it happens, when you get a response, let me know in this method or let me know in that method. Okay. So now let's go call this method in on resume. So if this all worked and we run it, our app should run, and when it starts, it will go through the life cycle of on resume, as it did, nothing break. But we're missing something. Where are our results? We need a result somewhere. So let's go to one more step. And to see our results, we need to work with our IDE again. So I need to get to our layout. So let me go up to layout, and I have my cursor here, and I'm hitting Command B on my Mac keyboard. to open my layout. And I want to go to design review. I'm going to pull over a text view like I did the button before. I see the handles here. I didn't do it well there, but let me constrain it to the top. Let me constrain it also to our other view. Bring it to the side and constrain it to the other side. Great. Let's give it the name users view. Okay, great. And because something has a reference to it already in the XML that was generated, we say, hey, refactor it and update the references. All right, but you know, this little text view, if we have a lot of users, it's not going to be enough to show us the names of all those users. So on this text view, let's go to attributes and look up lines. And here in the lines attribute, I can say 10. And what you see, my view actually got taller because it's ready to display 10 lines of output. Okay? So one more thing, let's go back to our activity. Okay, so now, again, like we did before, we find view by ID and our on create, and we say users view, find view by ID, r.id, users view, and so let's create here, private text view, users view. Okay, great. And so one thing we have to do, for time's sake, I'm going to copy the next little method. So I have to do something. Let's say if I have a list of users from our API, what am I going to do with them? So got a method here that says, given a list of users, create a string builder and append those names onto the string and put a new line character onto them. And then let's use this in our onResponse method. So up here in onResponse, I'm going to place this with that. So we got a response, we get the body response, we give display users. This does a string builder, appends everything, and it should be set into our new view. So let's go run that and see if that happens. Oops, something didn't work. Let's see. Next view, it's looking not right. What did I do wrong here? Users view is users view. Did I skip anything? We had a text view. Okay, let's double check this. We got a users view, we got find view by ID, and on create. Users, users view. Well, I'm going to show you guys how to use the debugger. All right. So, use this. Waiting for the debugger. That was weird. Debugger did not work. Let me attach the debugger again. Put it in the background. Oh, okay. I see what's going on. That just happened once when I was going to run it. I'm going to kill that. I'm going to uninstall this. And yes, I want to uninstall. There we go. All right, so you see a list of 10 usernames. Okay, cool. Okay. Last section, we're talking about persistence. So if you want to persist some data on your device, you have basically 4 options. The last 2 are kind of related. You have shared preferences, which are key value pairs. Very simple. It's stored internally in XML, but you don't have to worry about that. There's an API for getting to it. You could also do just file Java file I/O, so just like any other Java program. You also, SQLite is a lightweight relational database that is available on Android and iOS. So if you've done relational database, it will be seen very similar, except it doesn't have all the bells and whistles and administration tools that something like MySQL might have. It's very simple. Room is the preferred way to do persistence on Android these days. It's basically has SQLite underneath it, but it's an abstraction layer, and has a lot of advanced features, such as it can do compile time SQL checks, so to make sure that you're not going to basically have a failure at runtime, which with Room you could still have if something's wrong with your SQL. So that's the kind of preferred way. So let's talk about, okay, we got 2 minutes. Let's see, should we do this? Okay, let me try to do this in 2 minutes. A little exercise for shared preference. So shared preference are key value pairs. So let's go back to our main activity. And I'll copy and paste to not wait on my typing. But we're going to create a reference to shared preferences here. All right, and we'll take suggestion of the import. We are going to get this reference to shared preferences on our onCreate here. All right, and we get preference manager, get default shared preferences. Cool. And then in our on resume here, let's look at preferences and let's name count. On that click count we had before, we're going to assume that we want to remember how many clicks we had, whether our app is closed or not. And then in our on pause, we're going to store. So again, let's count. So basically, when our app is paused, it's going to save to shared preferences our variable count to count preferences. And when the app is resumed, it's going to basically get that integer and put it into count. So let's kill our app. Let's renew. Okay, so we're clicking here, we see click count. So our current click count is 4, right? So I'm going to put the app that's here in the background. In fact, I'm going to toss it away. So I don't want this app instance. I'm actually going to start the app again here. And then now we've started our app anew. And if I click here, we can see click count is now 5 because it basically persisted the number 4 when the app was went into on pause transition. Okay, so we're a little tight on time, but 7:30. I have a bunch of resources here of things that either I rushed over or couldn't talk about this evening, but these are all great links to check out in your own time. So that's all I had prepared for tonight, and so thanks.
Thank you, Chris. Thank you.
Thank you.
If there's any questions.
Cool. Yes, let me quickly share my screen so we can go through just the last 3 slides. Does anyone have any questions for Chris about anything he went over?
I explained it that well. There's no
All this code is available on the Google folder, right? Eventually, right? The slide and the recording.
Right, so the slides in the recording will be available in our drive, and you'll
Okay.
get that through an email. Chris, will your code be available?
all the code is in the slides.
Right.
Okay,
So
I'll check it.
everything he did
Yeah.
will be in the slides.
Okay, thank you, Chris. Thank you, Laisha. Thank you.
Sure. Yeah, it's all there.
Yeah.
There's no, yeah. Anything that I copied and pasted was actually from the slides.
Okay, I'll check them. Thank you.
Yeah, of course.
I have a quick question.
Mhm.
So for when you were talking about threads, for main thread, is it like some similar concept to event loops that you have in Node.js?
Yeah. So the main thread by default has an event loop already attached to it. So when the operating system launches your app, it, like I said, gives you a main thread, but it also has a main loop and a message queue attached to it. Now, if you start other threads, you create other threads, and you want them to have an event loop, you need to explicitly, using the API, that is part of the handler API, is to tell it, I want this thread to have a looper, and here's a handler associated with that thread. And via that handler, you can put messages on its queue. There's kind of 2 different types of work you can put on its queue, but it has a looper, so it's very similar to the concept you're talking about.
Right. Thank you.
Mm-hmm.
Any other questions? No? Okay. If everyone could just stay until the end, just 2 more minutes, we're going to take a group photo. But before then, we have just 2 more slides to go through. This is ACM slide, Melissa.
Yeah, so this is our Instagram, our Gmail, and the computer science Slack, LinkedIn, and we have our own website, which is the sfsu-acm.club. We post most regularly on the Slack, but our Instagram and LinkedIn are also very active. So please add us.
Awesome. Awesome.
Thank you.
And
Oh, Melissa, that's you. I see.
and SFX has the same. You can scan these QR codes to join our server or to find our other social medias as well. We are hosting more events coming up this semester into spring semester as well. On November 19th, we're going to have an IoT workshop presented by Arnaud Puder, who is our CS department chair. It's one of our faculty, which is pretty cool. 2 last things I want to bring up. We have our feedback form. So the response is the feedback form. Please fill this out if you guys have 5 minutes. It's super helpful for us to produce good workshops for you guys and just the student body in general. So please fill this out. It'll take 2 to 3 minutes. Another form that we have is our hackathon form, which will give us feedback on what you guys want to see in our hackathon in March. It's going to be a pretty big event. So we hope all of you want to contribute to it and list some of the ideas that you have.
Laisha, how do you access the forms? Is it also in the Google Drive?
The forms will be in the chat,
Okay.
and you will also see them in the RSVP email that we're going to send out after the workshop, and our
got it.
Discord and Slack and everything else.
I put both of the forms in the chat right now. The most recent one would be the Hackathon 2021 engagement form that Leisha was talking about. And if you look at the more earlier one that I posted, that would be the feedback form to help us improve
Okay,
future
thanks.
events.
Yep. Okay, now last thing, we're going to take a group photo. Most people left, that's honestly totally okay. I'm happy we have people that stayed in here. So if you guys want to turn on your camera and smile, that'd be great. This will go on our social medias and everything else you'll probably see. So I'll give everyone 3 seconds to turn on their camera if you want. No worry, Dale. No worry. Let me open the chat. So, no worry. Okay. Now on 3, we're going to all say cheese, okay? 1, 2, 3, cheese. Or I'll be the one that says cheese. Okay, thank you so much for joining. We hope to see you guys at our next event. You'll get flyers and everything sent out to you. Thank you again to Chris. If everyone wants to say thank you to him, that'd be great. He took the time out of his day to come present this topic to us. A lot of great information. So you guys can drop out now, and I'll see you hopefully soon.
Thank you, Chris. Sure. Thank you.
Thank
Have a good
you.
evening.
That was super informative and
Thank you so much.
great.
You're welcome. Thank you.
All right, bye everyone.
Bye.
Hope you have a good night.
Hi guys.
Thank you. Bye, guys.
Enjoy your Friday.